So hello guys, welcome to Backbencher Studies channel. So in the last class we have discussed how we can solve the overall transfer function based on signal flow graph using the Mason's gain formula, and we have seen how we can find out the isolated determinant and how we can find out the overall determinant, all of these. So let us solve this problem also. This is very interesting problem which was given in GATE. So let us do this. Let us solve this problem. So this is the signal flow graph we have, and here we have the 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 interesting thing here is we have the input over here and output over here. So we can have three forward paths. That is this one path and into one path. So we have the first path which with the path gain 1 into 1, and we have another path gain. If we observe, if we go to this node, and if we go to this node and again come into this node, and based on this, if we come to the output node, then that will be another path gain. So if calculating this path gain, we have 1 into 1 by s, the path gain of this, and into minus 2, the path gain of this, and into 1, the path gain of this. We have the this path gain which is equal to minus 2 by s, and we have another path gain which is of this kind. So if we travel along this node and to this node and to this node and to this node, and if we come back to this node and come back to this node along the loop, and if we go to the output node, we have this forward path. So calculating the path gain, we have 1 into 1 by s into 6 into 1 by s into minus 4 into minus 2 into 1. If we calculate that, that would be 48 by s square. So these forward paths are depicted over here, these two forward paths and the larger forward path. So let us find the loop gains over here. So here in this diagram, we can find out three loops, one with gain 2 by s, and with gain 3 by s, the small loop, and with the larger loop we have 6 by s into minus 4, that is minus 24 by s. So we have three loops that are being shown over here. So we have already find out the loop gains, and we have to find out the uh, determinant, the isolated determinant. If we isolate this path one, this path one is this one. So if we take out this node and this node and this node, we have these three nodes left. So if these three nodes are left, we have two loops which are present. So if we find out this isolated determinant delta of 1, which is 1 minus the sum of loop gains plus the product of sum of the individual non-touching loop gains. So if we do that, so we have these three only. So these three nodes are left if we take out this forward path. So based on that, there are no non-touching loops. So if we add these individual loop gains, that is 24 by s and 3 by s, to this we can find out the forward path determinant of forward path p1. We can have 1 plus 3 by s plus 24 by s. That is this bigger loop and this smaller loop. We have added that, and there are non-touching loops, so we have nothing to add it. So this is the determinant if we isolate the path p1. If we isolate this path p2, so what is this path p2? If we this path p2 is the entire path which is going to this up all the way to this node, and based on the loops we can. So this is the path 2 which we have calculated. If we isolate this, if we remove this path, we have no nodes left. all the signal flow would vanish and there won't be any loops. So if there all loops are vanished, we can have this forward path corresponding to this forward path P2, the isolated determinant would be 1. And if we take this forward path P3, P3 is this smaller loop within the smaller loop and coming back to output signal. If we do that, if we take out these four nodes, we are left with these two nodes. So if we have only these two nodes in the signal flow graph, we can have only one loop, one possible loop that is also non-touching. As it is only one loop is there, there are no possibility of non-touching loops. And with loop gain 3 by s, if we follow the same procedure in calculating the determinant, we can have 1 plus 3 by s over here. So this is how we can find out this isolated determinant based on isolating the forward paths and corresponding gains or determinants are found out. So we have to find out the entire determinant of the signal flow graph. How we do that? Based on formula. So the entire determinant of this signal flow graph is 1 minus summation of individual loop gains plus summation of product of non-touching loop gains. So if we do that, so if we do that, so if we do that, we have 1 minus of minus 2 by s, the loop first loop, and minus the second loop we have, and the third loop we have 24 by s. And if we see here, we have one pair of two non-touching loops. So that is this 2 by s and minus 2 by s and this minus 3 by s. If we product these two loop gains and if we add them, we can have 6 by s square. And using Mason's gain formula, if we substitute these corresponding values, P1, which is being calculated, and del 1 and P2 and del 2, and plus P3 and del 3 over here, and if we substitute this del, I forgot to mention P3 and del 3. So if we substitute this in the Mason's gain formula, we can have the overall transfer function as s square plus 27 s plus by s square plus 29 s plus 6. So this is how we can solve using Mason's gain formula. We can solve the overall transfer function. So thank you guys, and if you like my explanation, please do subscribe to our channel and please give me a thumbs up. Thank you guys. Thank you for your time.